we're looking forward to having fun and talking about macOS. So with that said, this is part 2. For those of you who are joining us here, it doesn't mean I won't review anything in part 1. I will talk really quickly about what got us here, what led us here, but I'm happy to obviously share any information from part 1. I think the slides and the recording and whatnot are already made available. If anyone does need any follow-up content or anything else they'd like to see, feel free to let me know, and I'm happy to kind of forward that on as well. I'm going to go ahead and jump right into it and get started. Let's go ahead and talk about part 2 of this particular part 2 of today's webcast or macOS threat hunting, and I'm looking forward to bringing this on. First off, I want to talk a little bit about LimaCharlie and macOS here. This is going to be, I think, a little bit of a refresher, but I do want to just reiterate for folks how you can utilize LimaCharlie with macOS, number 1. And then we'll get into some more MUL hunting and some things that I found during some research. And finally, we'll get into querying macOS data as well. So lots of good stuff lined up for us here today. Quick note for everyone. This is a refresher from part 1, but we do offer support for macOS in the form of an EDR agent. Does allow for, massive enterprise-wide deployment if need be. That last little bullet point is the one that I wanted to drop in. It's a little bit cheeky for sure. However, lots of other security tools out there got broken by the Sequoia macOS 15 update. We did not. And I'm taking that as a good thing. I'm going to assume that's a very, very good thing because we're still operational. So if you're looking for some sort of support, or you're on an MDR or an MSSP, or you got Macs in your environment and your platform isn't working, let me know, because we're still working on ours, but hopefully no other updates come out. Fingers crossed that I didn't just like jinx us and then Apple's going to be like, haha, let's find out why. But I do want to use this as a little bit of like a learning, teachable moment for everyone here. This is very common. I want to be very quick to call out because I've got lots of friends all around the industry. And the idea of Apple kind of releasing an update and that update breaking software, if you will, or changing the way that software has to interact with the subsystem or the underlying whatever in order to get something done. Folks, I'm going to tell you right now, that's very common. That's a very common thing that happens where, it's Apple has complete control over their source code, complete control over the way that things work. They do have the ability to simply say, hey, we're going to modify something in the subsystem that impacts our performance or makes it more streamlined for us or whatever it might be. And that may impact system detection, or I should say system tooling or third-party tooling down the line. This is a little bit of a warning because they may release an update in the next week that breaks everything else or upsets the way that kind of kernel instructions are observed or the way that the XProtect system works or something along those lines. I just want to drop that as a caveat for everyone out there. If you're new or haven't done macOS forensics, IR, interrogation, or rules or something like that before, then just understand that like this can happen. This can certainly happen, and it's possible, right? So just be aware that it's a thing that can go on, and it's not anybody's fault. It's just, hey, the code base changed. We've got to figure out the updates and see what happened here. You might be comparing this to like Windows, where you're like, oh, that never happened. Windows has got so much backwards compatibility, blah, 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 blah. You're not wrong there, but it's definitely an industry pressure that causes that. Whereas I feel like, and we're going to see some moments here where Mac updates some of the things that they do. And, a lot of times it's actually in the best interest of the user, or it's for privacy or for system and resource utilization and stuff like that. But with that said, let's hop into kind of like some of the refresher content here. One of the things that we talked about on the first part here, and that we're going to drill into a little bit deeper in today's session, is going to be the Mac Unified Log. This is the MUL, as you'll hear me refer to it multiple times, a centralized logging system that collects and stores detailed logs from the entire operating system. This is everything from user applications, system processes, kernel events, and as I mentioned, it's very, very, very verbose. This must be approached with caution. I am actually inserting this statement and covering this slide again because in the past 2 or 3 weeks since our first time, I've had multiple conversations with folks who want to start utilizing the MUL and literally just want to turn on a select star. Folks, I'm just going to warn you right here. If you are coming over from a primarily Windows environment and you're like, yeah, we just collect all the Windows event logs and we just kind of turn them on, right? That approach has to stop. That approach has to stop, because a lot of times when folks have that Windows event log centric mindset, that is often actually only 3 or 4 Windows event logs. A lot of times it's kind of like the system, the security, the application log, maybe a PowerShell log or a remote desktop log. But when they say turn on all the logs, there's over 150 Windows event logs that I know of that are enabled out of the box on a default install. The MUL has the ability to eclipse that tenfold. And I'm going to show you some screenshots and some examples of how that happens, but you do not want to just select star across these. Now, I'm being very like database in my speak here. There is no like log show select star, if you will, but just open up the console on a Mac OS and just click start and just let it go. And you'd be surprised that like me resizing a window can cause a dumb number of events, in addition to everything else that's running in the background. And we'll talk about how to look through some of those as well. When we speak about the console, that is the UI version. I've got a screenshot here, and there's some additional screenshots dropped in throughout this as well. But the way to access this via the command line is going to be via the command log show and then the predicate. Predicate, as I mentioned in part 1, is going to be the filter or expression that you're using to narrow down those log entries. And that can include everything from processes, the subsystems, timestamps, messages, so on and so forth. The way that we would execute some of these, if we wanted to do like a process or a subsystem search, would be as you can see on this slide here. So the first one obviously would be, hey, show me things associated with the Safari process. And then the other one would be, show me something related to the preference subsystem. A lot of times you'll actually see some duplication. It's going to feel like duplication between the subsystem and the process names. Sometimes they are the exact same thing. In other cases, the subsystem will actually be the daemon that runs that thing in the background. So we're going to talk, for example, one of the examples I'm going to bring up is going to be running board. And this one can throw you for a loop because the process would be running board. The subsystem is actually com.apple.runningboard.d for the daemon. So when you're crafting your predicates and then translating them over into LimaCharlie, which we'll talk about in just a second here, just be careful of what you've got declared as the subsystem and what you've got declared as the process. Obviously, one and the other can cause 0 results or can cause an abundance of results, just depending on how you've got it set up there. With that said, the way that we translate this into LimaCharlie is going to be inside of the artifact collection capabilities. And this is where I can take a macOS sensor and I can task it to tap into the MUL stream and send those logs up as part of telemetry. This is a screenshot from my last presentation where all I do is just simply illustrate, hey, the MUL events are running alongside your other EDR stuff, for lack of a better term, that's kind of running in there. The events are fully parsed out, displayed in JSON, easy for you to see, easy for you to read through. I already had someone reach out and ask, like, is it possible to convert that timestamp? Pretty sure the timestamp is going to align with the event time, but it does make it super easy to search and parse them if you need to. Now, all of that is a refresher. Did that in about 8 minutes. Wanted to quickly just kind of get everyone up to speed as to how we bring MUL data into our timelines and into our system telemetry. I want to start out with a cautionary tale only because we're future forward thinking here, which means I want to be designing MUL queries and predicates and whatnot. And I want to be implementing systems that give me detections I can use in the future. However, macOS will continue, as I called out in the beginning, to value the user privacy. They will continue to value system and resource utilization. Remember, they're running their own silicone chips now on pretty much every device that they bring to market. They've got the ability to say, oh, this is optimized if we do that. Therefore, we're going to do that and this. They value user privacy, and they continue to, tongue-in-cheek here, hide evidence. Let's look at an example. I pulled up this MUL query, and I actually ran this on my system and was extremely frustrated with the results. This is a really straightforward one. Show me DNS activity. The process mDNS responder is a thing of interest. And then I just threw in a little bit of a message qualifier to say, and show me where the message contains PID. Long story short, I want to see what processes are initiating what DNS requests, right? This should be really straightforward. Now, quick sidebar, I can use the DNS_request event in LimaCharlie to maybe see this a little bit more cleanly. But I wanted to know, based on the MUL, what processes are making DNS requests. And sure enough, that's in there. And I can see which PID or process is issuing DNS requests. In this case, there's a whole bunch of LimaCharlie sensors sending those out. But then take a look at that very last line right there. So there's actually some privacy built into the DNS request where some of the fields are actually masked and there's a hash value as opposed to the actual application or the PID or the user or whatever the details might be, or the site being requested. So in some cases, you will run into this field that used to display values. I found some screenshots online of a couple of years ago where folks were doing MUL hunting, and you'd actually see inside of the DNS query entries, you'd actually see the address being requested or the host name being requested. We don't get that in this case. In fact, I dumped a whole bunch, way too many to show in a screenshot, but I dumped a whole bunch of DNS logs and found out not a single domain was represented in them. Either that or I was looking for the wrong process. But you will see which processes are making DNS requests, but you will not see the actual event or the actual query name. Here's a better example. I've actually got this one zoomed in here of the DNS service query record. The queue name is masked, so I'm not actually seeing the result inside of my logs there. This is a straight up privacy implication, which is, we're going to hide what folks are requesting. However, I will make a note that I still find this not to be a completely useless query just because the data is masked, but I still think there might be some value in here if you were to filter out kind of non-standard processes, right? And I think this is going to be kind of like my first MUL hunting query where I might be interested in processes outside of things like my endpoint agents and my, config and my system applications and daemons or whatnot, making DNS requests. I think if you had like a malicious binary on there that was making malicious requests or was making requests, but it was doing something malicious with that information, I'd want to know that. This is not going to be an easy right off the bat detection. So this is what I'm going to be doing as we go through the different queries in our webcast today, is I'm going to be talking about the feasibility of actually bringing this into a detection and response rule. This one right here, I would not bring into a DNR rule. At the end of the presentation, or towards the end, I should say, I'm going to be talking about LimaCharlie Query Console. This is something that I would bring into the Query Console because I'm going to want to stack. I'm going to want to do data reduction. I'm going to want to slice this thing down so that I'd be able to see, hey, how many processes are making requests? Like what's normal inside of my environment? And I'll talk about how to do that towards the end. The next one I'm going to drill into, this one can be keychain activity. I also found that this was a really interesting way to potentially find use of VPN applications. Quick note, I downloaded and installed ExpressVPN on my system for you all, just for this presentation here. And I ran a quick query which said, hey, let me look for things against the security D subsystem. You'll also see this represented in the console as secd as well. And I was looking for instances where the message contained keychain. And in that, I got hundreds and hundreds of results. But I also found this really cool kind of screenshot where it picked up that I was using ExpressVPN, and this is a very strategically cropped screenshot. But it did find things being written to the keychain as the application was being installed and was attempting to run and whatnot. So I want to drop this in here as like two findings. One is if I'm going to do some MUL hunting or some predicate queries, definitely going to want to look for things that are impacting security D, because that's going to be a hub spot for not the application hub spot, but a hub or a spot for a lot of activity. And akin that a little bit to the security log in Windows. I'm going to be interested in some key events against that particular spot because it is a hub. There we go. It is a hub of security related activity. The end message contains is probably going to be the most important part of your predicate, whether you have it in a log or whether you have it in your LimaCharlie artifact collection, because it's going to help narrow down what types of things. I would even consider maybe sometimes entering a username in here because it is going to be like, hey, here's stuff that is probably more on the user level, the application level, as opposed to the system doing what it's doing. Because remember, on the back end, folks, the same authentication systems that we use to like store passwords are also used by Apple to store like basic keychain information. Like, hey, I need to authenticate to a known Wi-Fi network. Give me the information from the keychain. I brought this one up, very, very pointed, which is use of unapproved applications. In this case, use of an unapproved AI. I installed the ChatGPT desktop app just to see what type of evidence would be left on here. And sure enough, I found that I can actually issue a log predicate for process equals ChatGPT. And boom, I can see the process being used itself. I'm going to use this as kind of like maybe a policy violation query. I think this is one in general where you could insert a series of these, maybe in the form of detection and response rules or MUL queries. And it's kind of like a high fidelity finding. If this thing trips, it immediately gives me insight into what's happening, right? This is the ChatGPT process being run. This screenshot is from the console log, not the command line. However, there's irrefutable evidence here that a process named ChatGPT is running. Pretty hard to say that's going to be malware, but it might go against policy or it might indicate something that's happening on the system of interest, right? So I would use this, and maybe that process equals. You could sub out for the name of anything in particular that you might be interested in. I don't have this one in here, but I would definitely sub out maybe words like TeamViewer or LogMeIn, which are some of those remote applications, and those could serve as really high fidelity indicators, if you will. And I want to draw a quick distinction there for folks. I'm not dumping a process list from Apple, from macOS, and then searching through that process list for malicious applications. Okay. So I don't want to be like, hey, give me all the processes. If you see LogMeIn, it's bad. If you see TeamViewer, it's bad. If you see ChatGPT, it's bad. I don't want to go that route. I would rather drop in an MUL query like this, because this thing is 100% either policy violation. The fidelity is super high right out of the bat. So I can easily right out of the bat. So I can easily just say, hey, if this thing fires, I'm interested already, as opposed to searching through process lists and trying to maintain things that are there. So use these ones with some fun. This is another little subsystem within Apple that I found some interest in. I did some research and found that in some cases, you can get some really unique insight out of things. This is the TCC subsystem, transparency, consent, and control. It is its own subsystem, com.apple.tcc. And you will see things in here. This was actually me messing around with my address book, my contacts and stuff. And I was kind of actually just playing around, meaning I was opening some contacts, attempting to edit, things like that. And I saw that there were some messages being generated saying, hey, there's definitely some access and stuff going on here. Request, TCC system was certainly evaluating what I was doing, asking, hey, is this user allowed to do that? I think this can be another really useful, but also a very noisy query, something I would use with caution because you don't know what's going to come out of it. This one threw me for a loop, but then I remembered that a lot of these systems are kind of linked and tied in with each other. This is one that taps into the Apple Network Extension subsystem, so com.apple.network extension. But I have to insert a caveat for you all here. First off, this is going to be noisy as anything, number one. Number two, be aware of just how integrated your users have their macOS or iOS devices. I was seeing spillover on my laptop from my phone, and they're on the same Wi-Fi network, but I picked on Google Authenticator as one. However, there were multiple applications, especially like food delivery ones, that I know I don't have on my laptop, but I was seeing evidence of those network connections, or at least an attempt for some of those network connections through my console on my laptop itself. You might encounter some spillover data between devices. I view this as maybe a bittersweet finding. One, it could be an indication of what types of apps someone's using. And we're not mobile forensic experts, but hey, that was kind of interesting to see all the different food apps that I had making network requests. The flip side is you might get more than you want to actually see. So I'm going to go back here to this screenshot and just say that the network extension one can be good to pick up configuration changes. Notice I don't have a message filter on here. You will want to insert a message filter to look for specific network changes. And then we get into one that I found to be very useful. Again, very much akin to the Windows security log, changes in authentication, changes in things that may impact authentication as well. Full disclosure for everyone here, I have an Apple Watch, which is tied to this MacBook that I was testing on. And I am also using a KVM. I'm using a KVM manager and an external monitor. And this is what it looks like when I close the lid and just rely on my desktop or on my desktop monitor. First off, there's a message that says the lid has been closed, and then a whole bunch of authentication mechanisms check in to say, Is this a supported platform? Is this allowed to happen? And then I even found an error message looking for the Apple Watch. Now, if anyone here knows, you can configure your Apple Watches to actually serve as an authentication mechanism for your laptops or for your Mac systems. So if you don't have that kind of like Touch ID enabled, you can say, let me just double click my watch or double tap the side of the watch, and that can serve as an authentication mechanism. I love having this feature, and I love having all of these logs dropped in here because it gives me this unique insight of like, how has the user set up their workstation? Is any of this in a violation of policy that the organization might have? 1. 2, it gives me more insight into how my users might be using their systems. 3, folks, these are straight authentication messages, lid closed, logged in from console, logged in remotely, SSH history and whatnot. These are all authentication mechanisms or I should say authentication logs that you're going to get in Core Auth or the com.apple.local authentication module. I found this one to be super useful. It can get very, very noisy. I would use some message filters to make sure you're getting what you're looking for, but just note, like, this is actually a pretty cool thing to find here. Last but not least, this one is a potential, no guarantee that you'll find these in here. And I did mention that I would talk about Running Board. Running Board is one of Apple's kind of like process and error management monitoring style of things. I did insert a quick message in here and said, hey, show me things that are coming out of Running Board. And in this, I actually found some error messages that are associated with my username as I was intentionally causing errors to happen. But it did pick up on some of the environment variables for my particular user account. My home directory, the shell that I'm using, the SSH authentication sock, log name, so on and so forth. Again, very much one of those like accidental metadata log entries, but might be something useful on searching on. Might also be a really good query or an MUL to have in place for non-authorized users. So you could look at it 2 ways. 1, is there an admin user that I would want to alert on if that admin user was ever activated or ever seen? Or the flip side is no one but Matt should be using that device. So alert on any other user account that's on there. Now, I also want to mention within LimaCharlie, not only do you have the ability to go through and write all your own queries and tap into MUL, but there are also some super powerful extensions. I'm picking up on Velociraptor in particular, because in addition to MUL parsing, there's also some crazy pre-built options that you can use to look at things like browser history, auto runs, system preferences, users that are logged in, so on and so forth. But one of my favorite findings in doing this research was that Velociraptor also features an MUL-specific hunting artifact that allows you to actually search for all these different types of things across the MUL, bring that history up via Velociraptor or deploy it via LimaCharlie. And now, boom, I've got kind of a 1-2 approach. I'm also a fan of, recognizing that a lot of us are standing on the shoulders of giants. All the queries that Velociraptor looks for are wide open. If you're utilizing MUL predicates inside of LimaCharlie to bring some of this telemetry in, folks, go look at some of the ways that the queries are written and take a look and see if there's any subsystems that you might be missing or things that you might want to drill into a little bit further. I'm a huge fan of things like this, which is kind of like this, let me take a look and bring some configuration profile stuff into here so that I can manage and see those MDM deployments as they occur inside of my environment. Last but not least is the ability to query some of this data as well. Even with the best laid plans that we might have, sometimes timing is critical. We might have some of the world's most robust detections when it comes to macOS malicious activity, but if it happened in the past and detections are looking forward, unfortunately, we're going to have to search through historical activity. Luckily, if you're tapping into the MUL subsystem via LimaCharlie, those events are indexed for post-ingestion searching via the LimaCharlie Query Console. Past 30 days are free. Let me reiterate that. The past 30 days of MUL events or system telemetry in LimaCharlie's Query Console are free to search through. Just going to say that's the best place to test your queries and your concepts. And there's a really easy conversion option to say, hey, this looks like a really good query. Let me convert this thing into a detection, or let me go the opposite way, which is let me convert a detection into a query so I can view how does this thing look in the past and how might it look in the future. I wanted to give a quick example of kind of how to bring that together. So first off, I mentioned this in my LCQL webinar, which was a couple of weeks ago, where I said, get into the process of building your queries line by line just to kind of keep yourself logically sane as you're doing it. But I threw a quick example in here, which took an event from the background task management D and just converted it into a query. So the LimaCharlie query off to the side there takes or says, over the past 24 hours across Mac platforms, search through MUL logs and look for an instance of where the process is the background task management D. That's going to turn into exactly what you think, which is a list of events with background task management D. I went a step further in my query and I said, go ahead and use the projections inside of LimaCharlie to quickly stack and summarize this data. So folks, I'm hopping right to a threat hunting approach here, which is I want to know how many times background task management D has run and what it's done in the past. And there's a query that will do exactly that. It will take all of the messages from background task management D, count them, and then summarize them for you, grouping them into accounts so I can see what exactly has happened here. What has the background task management been doing over the past 24 hours? I can stack and sort appropriately. I can threat hunt. I can look and say, this is interesting, or this isn't interesting at all. It just depends. But regardless, I wanted to make it super easy and super simple to hunt through and utilize macOS data. Last but not least, quick summary over the past 2 webinars that have both involved macOS telemetry. 1, LimaCharlie makes it super simple to collect, detect, and respond across macOS environments. Deployment's simple. Telemetry can be as granular as you want. Process events, network connections, DNS, all the way down to MULs, different extensions pulling up. And I also want you to utilize, if you can, LimaCharlie's query console, and then utilize the telemetry replay as well to look for historical data. This is where you could build out your threat hunting. This is where you can test your detections. This is where we refine detection engineering approaches. And then looking forward into the future, we convert queries into DNR rules. We convert hypotheticals into DNR rules, and we wash, rinse, and repeat, continuing to hone and tune as we go on, looking forward into the future. That is what I've got for you today. For those of you watching the replay here, and you're kind of like, oh, I want some more of that information, you can get a copy of the slides inside of our community Slack. You obviously have the ability to pause the recording. And I would love to hear back if anyone's got any MUL queries that they've run or tested out before, or if something that I've put in the presentation needs to be refined. I'm always a fan of, hey, this thing's really broad, or Matt, you just turned on the fire hose. Here's a way to make things a little bit easier. With that said, everyone, thanks for joining me today. It's a quick brain dump, quick stream of consciousness on how to utilize LimaCharlie for macOS hunting and detection, and some more advanced MUL queries and things to look forward into. I'll just finish on this last note here. If you've got macOS presence inside of your environment and you're not familiar with the MUL or how to use it, I'm going to tell you right now, spend some time, go get a test system and get familiar with the MUL. Use it, use it, use it, use it. With that said, this is fun. I really appreciate everyone coming in and showing up for this one. Thank you so much for spending some time with us. And if anyone has any questions, you know how to get a hold of me. Find me in the various social platforms, LimaCharlie, Slack, Twitter, X, whatever it's called, Mastodon, LinkedIn. I'm all over the place. With that said, on behalf of the LimaCharlie team, thanks everyone. And look forward to seeing you all in the next one. Appreciate it. Take care. Have a great day and enjoy the rest of your week.